Hello and welcome to another repair video from Ellensburg Amplifier Repair and Service here in Central Washington. My name's Todd, and today we have yet another MD8K 2-ohm version Taramps amplifier. And for all you guys that watch my channel, you probably are starting to notice that you see a lot of Taramps. Now, I just want to point something out. It's not that these Taramps, they all fail. It's not that they all fail. The fact is that I am a warranty repair center for Taramps. So you got to remember, I deal with, well, the whole country. So I'm one of, I don't know how many repair techs we have for Taramps, but there really isn't that many. If you go on their website and look up warranty repair centers, you'll see the list of warranty repair places. So when you have, 300 million people in the United States and you have 12 technicians, I mean, there's a lot of potential amplifiers that need to be repaired, but spread amongst very few people. So I just wanted to make that clear. Taramps is not a bad amplifier. Hands down, period. They're not bad. Everyone likes to knock these Brazilian boards, but if they're treated right, like they should be, they do last for quite a while. Sure, there are some areas that could use improvement on these boards. For instance, the inductors. I've noticed a lot of inductors aren't secured very well, so they move around and they break off right at the board. So I've seen resistors come apart on the board. I've seen capacitors come apart on the board. So a lot of things, it just comes down to the fine details from the build house. This particular instance on this board, sorry, the transistors are all crooked. I literally just dropped this thing. This particular board has the typical shorted, blown traces. I see this on so many boards. It's crazy. I gotta support the center of this board here. It sags in the middle if I don't support it. And I don't like the board to sag because it puts a lot of stress on all these fine traces. Back to what I was saying. I see this all the time. Blown traces, blown traces, blown traces, blown traces. Broken inductors, blown traces. I'm starting to see more blown power supplies though, but I think I'm getting closer to an answer to that. I don't have an answer yet though. But blown traces and broken inductors are the two biggest, most common failures I see on any Brazilian style board. Two most common. The third most common that I'm starting to see are blown power supplies with no shorts in the output. That's a little different story. Still working on that. I've had several in that have blown power supplies with no other failures. Odd. Usually when you have a power supply that fails, it's because the output section shorted, going through the rectifiers, taking out your power supply. I'm starting to see that is not the case on a lot of amplifiers. So I'm still working on that particular cause and solution. Waiting on answers. So again, this does have blown traces. So there are quite a few traces on this that are blown. I got to get rid of some of their silicone here. So what I do is I just take my scalpel, cut a line right across it, and then I take my tweezers and I go right underneath that silicone. And you can just peel that silicone up. So on something like this, what I'll do is I'll replace the transistors. I will replace the Zener diodes. They're 15-volt Zener diodes. The gate resistors, depending on the failure, sometimes these things will fail, not substantially, and the gate resistors will be just fine. It just usually blows a trace. But some failures fail drastically, which takes out a lot of things. Luckily on these boards, there's not a lot of components to go south during one of these shorts. This does use the SI8244 output IC. And just as I suspected, underneath that silicone is another blown trace. So it took out all but one trace on the top. Just trying to clear the silicone here. Silicone's not my most favorite thing to use to secure stuff down. It's highly flexible. You still can get vibration damage. You can still get your inductors coming apart. So silicone, in my opinion, is really not the best choice to use to secure components. Sorry for the fingernails on a chalkboard sound here. But that silicone, if you just run over it with the tip of your tweezers, it'll just peel right up. All right, so let me flip it over and see what we got on the bottom. I just took this out of the heat sink before I dropped it on my bench here and spilt isopropyl alcohol everywhere. But let's flip this over and see what we got on the bottom. Indeed, yes indeed. So what we have is, you can see it right there. We have a pretty wide blown trace here. That's going to be a really wide area to repair. Just double check and make sure there's no other blown traces here. No, looks like it's just that one on the bottom here that failed. Yeah, all that surge current when these get a short, all that capacitance in those rail capacitors have to go somewhere. Electricity always finds the quickest path to ground. Always, always. Let me see. This is probably vaporized copper here, so it's going to be a little bit more difficult to peel up. Yeah, not too bad. A little bit of vaporized copper. Yeah, so when those traces burn up, it creates this really hot flash, and that hot flash will take any copper or any metal that's around it and vaporize it, almost like a big plasma ball, and then it gets adhered to all the surfaces around it. So we'll replace the transistors, which use the IFB 4127s. Again, another common transistor that's used on these. So we got 4127s here, IRFBs. We have the SI8244 drive ICs. We have the 1404s in the power supply. Just another common, typical setup here. I don't see any failures of components, as in diodes, protection transistors. I don't see any shorts of anything else. So I'm going to go ahead and flip this over, and I'm going to remove all the transistors. Sorry about that glare again on these fantastic lights of mine. It'll take just a minute to pull out these transistors. Keeping in mind too, you're going to have two rectifiers here. So this is where the power supply ends. This is two rectifiers, and then your outputs are here. So it's 3 and 3 on the output transistors. The Hakko FR301 is my tool of choice for desoldering. It's quick, it's efficient. And it's a lot easier to clean than the 808. The old school 808. Still have it. It's on the other bench. A dual pump versus a single pump. That's the difference between the 808 and the 301. This is just a single pump, which is nice because it's a little easier to clean that way. And last but not least, just like that, I will grab my scalpel and I will remove some of the, what do you call this stuff here? The solder mask. Sorry for the fingernails on a chalkboard sound again. But, you know, we got to do what we got to do here. So I'm going to remove a good section of copper here. Brush it off with my brand new clean toothbrush. I'm going to pre-solder the area that I just scraped off. Looks super fantastic. Thermal paste. Oh, God, I can't stand thermal paste. I know, I complain about it every time. Sometimes my wife will say that I complain too much, but I really don't think I complain too much. So we got all that out. I'm going to check continuity on the Zener diodes and the gate resistors. Continuity? No, I don't use continuity. Resistance mode. So you're going to have gate resistors, of course. 1.1 ohm, 1.2, 1.1. Let me see what the value is. I think they're 1.2 ohm resistors. Oh no, they're 1 ohm. 1R0. So my meter, when you short the leads together, is a 0.20. So there's 0.20 ohms of resistance on the lead itself. If you check the resistor is showing 1.20. So it's exactly 1 ohm. And now there's a resistor right next to it, which should be a pull down. And the pull downs are, I should have looked while I was there, but I didn't. Sorry about that. 1.8K. So 1802 is 1.8K. So I'm reading across that, and I'm reading 1.40 ohms. So we have a short somewhere. So 1.40, I am reading the 1 ohm gate resistor plus my 0.2 ohms on my meter leads. So I should have, looks like I have a 0.2 ohm short. The Zener diode is reading 0.36 ohms. So that is a shorted Zener diode. Just to let you guys know. And of course, you know, I'm more than likely going to have to, I'm going to have to replace all these Zeners. Yeah. So your pull down resistor, you should read your pull down value. Your gate resistors, you should read your gate value. 1.21, looking good. 1.31, so I think that's within its 1% tolerance. I think 1.23, good. What do we got here? We got 1.21, good. 1.22, good. And the pull down, 1.44, not good. So I'm going to remove the Zener diodes, all of them, real quick like, and see if that changes my pull down values. So on output failures on these Brazilian boards, it's best to change your Zener diodes as a good precaution for the integrity of your repair. Just let you know, replace your Zeners. There it is, the Zeners. Zeners are out. Now let's check those pull downs one more time. There it is. Now we're looking promising. All right, 10.3K. Oops, looking like the drive IC survived. Oh, what? .51 ohms across that pull down. That's not good. So, as you can see, I just do the process of elimination. Now, that pull down is directly across the gate drive IC. Gate drive IC, the Class D audio IC. The SI8244. So I'm going to remove that SI8244. And check that pull down one more time. Oh, 1.46. That SI is probably okay. Why am I showing? Oh, hey, Todd. It helps if I pull all the Zener diodes. I've got one Zener here that's kind of hiding underneath some silicone. Never fear. We'll pull it right off. So that SI8244 is probably okay. I was chasing my tail. There it is, 10.3K. 10.3K. That's exactly what I want to see. Well, let's go ahead and clean up the pads for the SI8244. That way I can put it back in place. That's okay, you know. You win some, you lose some. and my phones are on business hours. I am open, so you may hear my phone every now and then. This is a customer that dropped off a salt 12K this morning, and with a very, very substantial failure on it. Oh, and I got someone coming to drop off a CT Sounds Team 4000. Busy, busy. Guys, you know, this business never slows down. You know, I always say I try not to work on Sundays. This last 2 weeks I'd gotten to a point where I could comfortably say that my turnaround time was 3 to 5 weeks instead of the standard 4 to 6 or 5 to 8, somewhere in there. But I'm slowly creeping back up to that 4 to 6 week period again. I've gotten so many amps in the last couple days, so I'm going to be probably working some long hours to try to keep things caught up. It is competition here in Washington. There is, what's it called, Surf City or Surf and Sound or something of the sort, competition that everyone keeps asking me if I could make it there as the local repair guy, but I just don't know if I'm going to have the time to make it and show myself. So I'm just going to solder this SI back in place here. These are super expensive ICs, so I'm would be more than happy to just put this guy's IC back in place for him so he doesn't have to buy a new one. My current price on these ICs are $110 each. So I don't mind helping customers out, and if a chip is good, I won't replace it for the heck of it. They're too expensive to do that. There. And then I can go back through again and check the resistance values, which will tell me if the SI8244 is still okay, which I can do by going across that gate or the pull down resistor again. There we are. That's where I should see it. Remember, they were 8.2K resistors. So 7.1K, slowly climbing. And 7, 9, 10, perfect. 10.2. Should be closer to 7.5. Oh yeah, there we go. 7.4, 7.3, 7.4. It's almost at 7.5K. And what you'll notice is on the other side, so 10K on the other side, and we've got 8K, but this is without transistors in, so I am reading the values that I should be reading with that SI8244 in place. So with my positive lead on the gate, so it should be 6.8. So positive lead on the gate. 6.9. So yeah, we're right there. Looking good, looking good. I do believe that SI to be just fine. So let me get some isopropyl alcohol out. Sorry for my arms across the camera. Clean up the flash burn here. So the copper that gets embedded on the top here when the plasma ball gets fired up, that stuff that you get to see burn on the board is conductive. So you want to get rid of all the flash burn on the board. You don't want any stray inductance anywhere, skewing the signal going to the gates. You want this to switch just as efficiently as possible. Then I'll take my scalpel blade again here and get rid of the coating on the top. On each trace that failed, which is all but one, so which is no problem. I've done this 100 times. And of course there's traces that are just right up against the capacitors. Sometimes I take the capacitors out. It does help me gain access to the area I need to work on. But we'll see what we can do with this today. Maybe. Looks like it may have blown out that whole trace. I may have to pull that capacitor because there's no trace left. I don't really want to pull it because it's nicely glued to the rail cap. So I am going to try yeah, that's a tough spot. Looks like I may have. Oh yeah, it's going to be pretty difficult to get some solder up underneath there, but I think with a little bit of heat we can get it done. So the Hako is still on, alive and well. Get some solder put on this bare copper so it doesn't oxidize, pick up any nasties, so nothing sticks to it. Ah, boy, that is... Boy, I got right up underneath there. That's called luck right there. All right, so I got solder on all those exposed traces. The gate resistors, they did check out fine and dandy. So let's Let's, do I want to put the Zeners on now, or do I want to wait? Nah, let's get those Zeners on now, so we don't have to fight them later, trying to squeeze them up into the area where the transistor legs are. So let me find my Zeners here. Zeners. 15-volt Zeners, of course. I've got 15-volt Zeners for days. How many do we have? 6. So 1, 2, 3, 4, 5, 6. Yes, I can count. Sometimes I question my abilities. I know you guys probably say, "Oh, I shouldn't question my abilities," but we all have our bad days. All right. And you guys are seeing in real time here, we're all real time, recorded real time, just how quickly one of these amps can be done. So there's my new Zener diodes. Get my thermal paste here. And the board is marked what direction they go in, which is nice. I like it when boards do that for me. You know, they mark the direction, cathode and anode. See if I'm not, make sure I'm not forgetting any. 1, 2, 3, 4, 5, 6. All right. Now I'm just going to place them in that thermal paste in the right direction. Thermal paste. Solder paste. I'm not tired. I like it when they do their best to lay them all out in the same direction. Uniformity, is that a word? Uniformity? I like things to be uniform. Quick and easy, just the way I like it here. And that's how quick Zener diodes can go back into place. Now I need some transistors. Or sometimes it's hard to hear me while the hot air gun is cooling back down. So I try to be a little quiet while it's doing that. All right, so we are needing some 4127s. I need 6 IRFB 4127s. Six IRFB 4127s. 1, 2, 3, 4, 5, 6. All right, we got 6 IRFB 4127s here. Make sure they're all the same code. Yes, yes, yes. And as I had mentioned before, what I do is I just slide my finger underneath the board here, and I just feel for the legs just to stick through the board, and I bend them in small increments because it does spread the legs out just a little bit by design on this board, as to reduce the stressed areas of transistor legs, because that's usually where a transistor leg will break, is if it's got any stress applied to the leg itself. So if you just bend them in small increments as you slide the legs down in there, it should end up kind of like that. So that is the curve of the transistor leg itself. And again, they are spread out just a little bit. These TO220 vias are not exactly the width of a TO220 transistor. So it just goes back to reducing the stress of the leg of the transistor. And then what I'll do is I'll tack one side of the leg, because my primary goal is to flip the board over. And usually I'll do the gate when I do this, because it's less, it's got less thermal mass, so it doesn't take long at all for the solder to flow into the gate via. So now I will go through and solder the rest of the transistor legs in place. With the Hakko FR301. You remember, guys, when you're soldering your transistors in, be mindful of solder bridges. Just as a little word of precaution, I have had, I still don't know to the day if it was a solder bridge or something on my mat or something was underneath the board, but when I fired that amp up, it blew up like a firecracker. And just, it was crazy because I could not determine what caused that to happen. These run at such a high voltage, it just vaporized whatever was underneath. So I don't know what caused it. And now I'm just getting myself some copper here to repair the trace. Might be a little too wide. I don't want to get so wide that I'm shorting anything else out. Squeeze the copper to fit. And that is a repaired trace on the bottom side. Oh, let me see here. I might actually have to use copper plate on that big one underneath. That's kind of underneath the capacitor. It's a pretty substantial area that's missing. I will determine that when I get to that one. But in the meantime, I will go ahead and get these other ones all fixed up here. Trying not to get the transistors too hot. Although these transistors, they can take quite a bit of heat before you have junction failure. But still, it's best to treat your transistors nicely so they have a long and plentiful life. And let's see here, get the next one put in place. Nicely well done. And then the next one. And one more. And then of course reinforce the trace of the one that didn't fail, so it doesn't fail in the future. And then we're going to repair the one that really got pretty wide. And at the same time, I'm going to flow these other traces here a little bit. And now figure out what I'm going to do about this one last trace that's probably one of the, I don't want to say the worst I've seen. It took out a lot of copper. So I'm just going to see what I can do here. Kind of a tight little area, but nothing defeats me. Maybe. Sorry for the arm over the camera here, but I got to try to squeeze in a little. Oof. Boy. Did I get it? Did I get it? Oh, I think I did. Is that going to be pure luck? Or what? Nah, there's no such thing as that. There we go. Gorgeous. That's all I can say about that. Gorgeous. All right. Zeners are in place. I'm going to double check to make sure I've got all the Zeners soldered down. If you've ever put Zeners in and you fire the amp up and it makes like crackling noise on you, well, that's telling you that you don't have a Zener that's soldered down correctly. I just thought I'd point that out to you. And yes, I have done that. I would miss like one side of a Zener, or I'd forget. Oh, like that. That was not soldered in place. That would have told me real fast that it was not happy. But never fear. I think I might have got it. Just to double check it, I will use the Hakko FX888 soldering iron to double check that. And in the meantime, while that's warming up, just takes a minute to warm up, I am going to double check my resistance here. Perfect. 8, 10, 10. Look at that. Perfect. So far, so good. 8, 10. Most excellent. I'm just going to double check the solder joint of that Zener diode. And it is soldered down nicely. There it is. I do believe we have accomplished what we needed to accomplish. All right, where did I leave off? Sorry, I had someone come in, drop an amplifier off. The guy that had that, what is that CT Sounds. So, where was I? I was going to check the resistance value of my transistors. I do believe, because I just got done soldering the Zener diodes. Just making sure I don't have any solder bridges on the trace repairs here. It's good. Fire up the meter. See what we have. 10.59, 10.62, 10.72, 10.58. Excellent. Perfect. That's exactly what we're looking for. On the Zener diodes, I need to see here. So the Zener is straight to ground. I'm just double checking, making sure my Zeners are connected the way they should be. To ground. Gate to ground. Gate to ground. Gate to ground. Perfect. And last but not least. Nice. All right, I'm going to make sure I don't have any shorts across the drain and source. 58K. 83K. I'm just going to make sure I don't have any shorts here. I've done that before where I would have a solder bridge that I missed, and it does not fare well with shorted drain sources. So 37, 36, 37, 80, 39, 80, 39. All right, looking good. So let me make sure that my power supply is not shorted. And I see capacitors charging, which is good. Rectifiers look good. I do believe we are going to be okay to fire this thing up. All the potentiometers are fully counterclockwise. Boy, this RCA jack has seen better days. And hook up some power here. The remote, I'm going to need to get another jumper here. And we will see how well this works out here. So I'm going to flip it over, just double check the underneath side here, make sure there's nothing abnormal. Turns the power on. Blue light comes on the power supply. And it starts up. Just like that. All right, I'm going to check DC offset. So let me get my meter set up here to check some DC offset, which is sometimes kind of hard to do. Since I don't have my leads tied down into the output. All right, so let me flip this board over here and we will get the leads tied in to the board itself. I really don't care about positive or negative because I will adjust it down to as close to 0 as possible. regardless of polarity. And I'm not sure if I've mentioned it before in the past, but when you do these Brazilian style boards, it's always best to make sure that your DC offset is properly adjusted. All right, DC volts is set. Let's go ahead and fire this back up. .043 of a volt. .000 DC offset. Exactly what we're looking for. So, do we have switching? Is the next big question of the day. I'm sure we have switching because it did not give us any indication that there is an issue in the drive, because it will let us know if there's an issue in the drive. But just to show you guys that this amplifier is up and running, I will fire up the scope here. There's the scope there for you guys. And let me find my probes. Kind of got things everywhere. It's been a pretty busy day. Let's see if I can do this with free hand here. I'm going to fire it back up again. And there's the switching, as you can see on the scope. Why did that look so bad? I did not like how that switching signal looked. Hold on. There's no heat. This is my, I'm sure my scope is grounded. Yeah? All right. Hold on. So that is a signal that I just don't like. So I'm going to disconnect my meter leads here. All right, we'll flip back over. Where do we want to do it from this end? Let's go ahead and go from this end. Oh, that SI, hold on. That SI8244 is what we call not a happy camper. So it more than likely did damage that SI. Just by looking at how the drive was. Since this does not use any drive buffers, Let me make sure that my flux is not affecting the signal. Make sure all my pins are soldered down. Yeah, that is not a correct drive whatsoever. It should look something like that, but it's kind of just getting skewed because of the feedback. So let me double check the feedback circuit just to make sure. I may have to replace that SI chip. And the feedback circuit looks great. So we are going to work with a new SI chip, which means I'll have to set that DC offset again. But we got to be real careful because of the rail voltage. As you can see on the scope there, we have rail voltage still present at about 142 volts. It uses a 68K discharge resistor. We're going to pull this SI off. And put a new SI on there. Let me find one. SIs are getting a little thin. All right, SI 8244 BBIC. All right, got one left here. And we're going to clean up the solder. While I'm waiting for the Hako to heat up, I am going to double check my 15-volt Zener. good. That's what I thought. Yeah, it's gonna be that SI chip. I probably cooked it when I took it off. All right. All right. Okay. Let's new chip with some good old Amtech flux here. And the soldering iron. Now let's try this again. I was hoping to not have to replace the SI chip, but unfortunately, I think that is giving me my bad gate drive. So we just gonna have to replace it. The old isopropyl alcohol here to clean things up. And just to double check I got it on the right direction, IC dot faces the notch on the board. All right. Shall we try this again. I think we should, just to make sure, hopefully, that we have resolved the issue. Let me double check and make sure with my magnifying glass here that all my pins are soldered in place, and they are. All right, here we go one more time. Power on. What does our drive look like now? Oh, look at that. That's the way it should look. That's how it should look. The difference between a good drive IC and a bad drive IC. Perfect. That's exactly what we're looking for. Oh, but now, guys, you know what we got to do again? Even though I think we should be okay, we need to check that DC offset. Just in case there's a, you know, if there's a slight variance in the drive between the old chip and the new chip. The old chip was giving us a bad drive signal, so now my DC offset is probably off. So I'm going to go ahead and prop up my leads into the speaker terminals here. There we go. Fire it back up again and adjust that DC offset as needed. If I can get it started here. .077. I'm going to bring that down just as close as I can to 0. .003. There it is. 0.000 or 0.001 as the comparator tries to bring it as close to 0 as possible. And there's that DC offset. So you should hear absolutely 0 speaker thump when you turn the remote off. Nice. And there it is, guys. A new SI8244 IC had to be installed. Most times those ICs survive. Most times. This is the first time I've had to replace one in quite a while, to be honest. So that is the repair and rundown of this MD8000.1 2-ohm amplifier. Again, just another simple repair, trace repair, replace transistors, and replace the drive IC. So I'm going to go through and reinforce the other side of the traces here so they don't burn up, and glue everything down and put this all back together. I do thank you guys for watching. Again, please stay safe. Keep your fingers out of the rails here at the rectifiers. You saw it was about 180 volts on this thing. So you want to be super careful about where you put your fingers in relation to ground. So stay safe out there. Please feel free to leave your comments down below. I will answer them as soon as I can to the best of my abilities. And we will catch you on the next one. Thanks for watching, guys. Stay safe.